the story of ESDL. ESDL stands for Energy System Description Language. And I'm Thomas van Dijk. I work at TNO, and we have a new group which is called the Digital Transition Energy Systems within TNO. And this group started a couple of years ago, and I'm very happy to be here. I was at the last summit, and I really love the energy and the ideas that all come together to actually make this happen in a proper way. And I think applied research organizations might have an important role to play, both on the standardization part, but also on bridging the gap between research and industry, and maybe also in helping some of the open source developments to scale to other market players. TNO is the Dutch Fraunhofer, a bit smaller. Not sure if we're more agile. We have many different locations and lab facilities. I see some labs here. Are you from Fraunhofer? No. Did you experience the agility of Fraunhofer or TNO? So there's many different labs, and there's also a part which is the ICT strategy and policy part, and that's where we work. This is how an agile structure looks like. So there's many different propositions from digital systems where the digital transition energy systems is, but my goal particularly is to actually tap into the minds and hearts of the people that work also in data sharing and AI, in the data spaces, in setting standards there, but also in cybersecurity, in developing security playbooks, etc., and basically merge that into a digital proposition for the energy sector. That's not what I'm going to talk about today, because what I'm going to talk about today is more data semantics and something that TNO has developed, which you could call an ontology, a data model, or a taxonomy. And I think that's an important part to, amongst us and other people in the industry, to agree upon and to start converging towards one uniform way to describe energy systems. Because if we look at the entire chain, you have your energy system description, which twice SIM, so the top one is ESDL. Maybe this is also a message from the universe that SIM obviously is more popular at the moment than ESDL still. You have your user interface, you tap into your data resources, we've heard many times today, into your models, and then you reach your end user. And I'm going to briefly walk you through how we do this, and then of course invite you to join us in this journey. So why did we start this? You say there's already twice SIM on the last slide. Why would you need ESDL? So we noticed that the interoperability between all these different models was very poor. And this models not only modeling electricity systems, but also heat networks, gas networks, etc. The transparency on what kind of assumptions are below these models, what kind of data is used, and what kind of sort of calculations are being done on them is very poor. So there was a study in 2050. Well, basically, the take-home message is 3 kind of respected institutes were asked, like, how does the future look like? And all 3 of them said something completely different, which is obviously fine. But at least it would be nice to track the assumptions they all made to see, like, hey, where did their visions diverge? And then there's the challenge of aggregatability, which is already in a small country like the Netherlands with the different DSOs, the different provinces, that they all do their study. And, you know, in the end, you want to have sort of a one national plan. and aggregate all these different studies, which is impossible. So what you'd need is an ontology, a data model that they would all use their own different type of models on top of them to solve these three challenges. So that's what TNO started off developing, and it started small, became a bit bigger. There is sort of different levels of abstraction in this data model, from sort of the level of an energy system down into energy assets. And it doesn't go as detailed as SIM does, but it does go down to the asset level. And it's quite vast. This is what it looks like currently. And the things that are captured in this beautiful chaotic model are basically system components and topology for both gas, electricity, and heat, spatial information. You can add profiles to the different nodes, to different ports, obviously. And there is all different technology information, which more relates to the data source part. And then there's all these other things that you can then add to it. But in the end, still, it was a very large hierarchical model that was built. And it was only until, so sort of, okay, you have your ESDL, you need your user interface. So it was only until there was a user interface built where you can draw your system on a map and an ESDL is directly created that it started to get traction. Other people in TNO started to actually use it. Say like, hey, this is quite easy to use. You could select your different asset you'd have. You could add your profiles. You could tap into profiles that were used in other projects. And it started to be very practical. So, okay, we had the user interface. And over the years, this actually sort of exploded in our face. No, not really. I mean, there were all these different models and different research groups that started to build things on top of the map editor and integrate different models from, well, Masaido for more networks on the North Sea, to energy system simulators, to market models, to wind models, to district heating, network optimizations. So there were different parts, different labs at TNO that said, hey, this is actually very useful. I can draw now my energy system in a way, and I can communicate this to the people that work on the simulation models. So there were different application domains that started to use these different tools. And at the same time, we also started to create a data repository, like the energy data repository, where we store different profiles to use, standard profiles, both in consumption and production, which makes it really easy to start filling your ESDL model. There's the Midden database that was created with all different types of industrial processes captured and translated into ESDL asset pictures and related information, so that you can easily tap into different industrial processes if you want to take them into account. So, okay, this is your data resources part. Then there are different simulators actually used and developed by TNO. One of them is ESSIM. I won't go into it in a lot of detail, but it is interesting because this was something that was fully configurable in ESDL and was able to create different scenario simulations and answer questions that were quite relevant. So is it well dimensioned? Is everything in balance? Is there a particular area in the grid that will be a problem in future? What are the effects of adding this or that asset, etc.? So, okay, this is the energy system simulator that was used. Then you do need also an end user in the market to actually have it use this entire chain in order for it to become valuable. So both ESDL and ESSIM are open source. There are quite a lot of tutorials out there. And the tutorials, they walk you through how it works, what's behind the curtains, something that I currently will not do. What I will show is that some of the things that are happening is that once at TNO is that once you do have your energy system and your ESSIM engine, that you can then basically use different transport solvers for different type of carriers, whether it's a heat or an electricity or a gas network. And you can also easily replace your solvers with something else. Obviously, it can be Panda Power. We are currently working on Possible. And after the last presentation, obviously, I cannot but only say that I hope that we will also integrate it with the power grid model. The company that started to download this, follow these tutorials, and actually use it in daily life was a fairly large company. And one of the things that they're also very interested in is replacing certain modules. So adding their prediction model for EV charge times for a particular customer. And that large company is Equins. So it's a very large engineering consultant firm with 60,000 people worldwide. Unfortunately, they don't all yet use it, but there are about 50, 60 in the Netherlands that have downloaded this software and started to use this in their daily work, which made us obviously very enthusiastic because we can then add the last important node to our chain. So to come back to what I said earlier is the applied research organizations of this world that get state money, as TNO does, Fraunhofer also, I imagine. I think you could create something for industry, you could see if other industrial partners want it, and then it's time to find independent implementation partners to actually have it scale. There is, at the moment, sort of discussions with these implementation partners, and this is the search, sort of how to, what we now have. We have a end user that happily uses it, wants to pay for it, but I'm not sure how much, and then what for, and then would you start first build a community, start and ask for a contribution fee, or so these are questions that run through my mind. So if you say, hey, I know I have some of the answers in my mind, yeah, it would be nice if you share them with me afterwards. There's a couple of other tools that I can show you because there's, you saw the exploded view of once we had that interface and all the different models that were able to then be executed from this interface. One of them is the sort of a spatial energy explorer, which is one of the latest. But I think I won't do that. I will run through the slides because I guess you get the message that there's all these different type of simulations that all of a sudden become possible once you've created a common ontology to describe your energy system with. An important development that we see, though, is that at the moment, sort of this user interface, we built the map editor ourselves, which makes it easy because then you can sort of integrate all these different tools and use it internally in projects to advise others. There was the people group in one of the companies, which is a commercial company with a lot of experience in geospatial platform building. But there's also ESRI that we currently have a conversation with to actually see whether they can include ESDL in ArcGIS, which would obviously be amazing, because once that would happen, I think it's also an important discussion that I already started today with some of you, and actually a bit earlier, is you have all these different standards. Is ESDL the best one? I kind of don't care. I think what would be nice is if we converge on, on the left towards something that works for everyone, and if that's with interfaces or adapters, fine. But I think it would be great to develop them in an open source manner so that we can actually quickly see whether it made sense. Once you have commercial platforms like ESRI join the journey, I think for us that'd be extremely exciting because then it would mean that all the different models are accessible for millions of people. We've documented it fairly well, maybe a bit too well, because a TNO organization does projects, and then the risk is that it does become sometimes a bit of patchwork-like. Maybe sounds familiar. Then there is beta project manager projects, to then help solve the complexity that you've just created. But in the end, once we see that this starts forming, to come back to the question that was asked at the start of the day, less talk, more code, or more yoga. Maybe, but I also see that at the moment there's a need to form a community and structure this code and these data models and sort of structure the strategy that all these different initiatives take in order to align the data, the models, and the ontology that they use. So this is something that I've already mentioned, and this is something that what I'm thinking of having sort of an ESDL open source core as an open standard, which would be a bit better than SIM, because you could obviously develop it quicker, and then have a strategy where you develop your tools first internally with companies and then bring them to the outside world. Next steps, I think I've also all mentioned them during this presentation. I hope that we can jump on this train, moving towards graduation at some point. Some of the questions that are, at least on my lips at the moment, is, do we join the Linux Energy Foundation? And then is it with ESDL as a data model or ontology, or is it with some of the open source models that we've built around it? Not sure. I'm not sure what the time is, but I would like to... Oh yeah, 10 minutes left. I think 10 minutes is nice for questions. And obviously I'm aware of this situation that people think, hey, wouldn't it be amazing if we develop a new universal standard? Yes, that would be amazing. Tomorrow there's actually a meetup at 11 where we meet with different people working on different types of models using different ontologies. So if you do work on a model, if you have an opinion on the underlying data models and basically want to join yours to the list, please join tomorrow. You can already fill in your ontology used, but you find that in the details of this event tomorrow. We create a table, and every model prepares a short pitch to say, like, hey, this is the type of solver we use, this is the optimized, this is the underlying ontology, and then we sort of go and see, like, hey, where should these adapters emerge? Where should we converge or maybe diverge? Yeah, thanks everybody. I do have my colleague also here, Jorrit Nutma. He is one of
Microphone.
he's one of the developers of at TNO of several of these models. Do you want to add something now already, Jorrit?
Let's see if we got some questions.
Yeah.
Yep.
Any questions?
People thinking.
Was that a question, Tony? Was that a no?
Yeah.
I wonder how you think about you mentioned different ontologies, and as a software developer, I can from that perspective I can understand why people choose different ontologies at the model level, so the calculation level, because you want to design a data model which has minimum overhead to your own software engine, and that is because when the user want to extract the last piece of the performance, they can choose to match their data model to exactly yours, so they can benefit the last bit of the performance boost they have. Of course, that's not the way of thinking when you look at the data model perspective, look at the universal data exchange perspective. I wonder how the ESDL can balance these two.
Jorrit, do you have a first answer coming to your mind? Or?
Yeah, so if I understand it correctly, it's mainly about how do you internally in your tools use your data representations. Is that ESDL based or something native to the model? And then the answer is adapters. So ESDL is really meant to provide uniform inputs, but then you have to translate that to the data structures and the way you represent data in the model. Yeah. Okay.
So one thing that would be nice, because this is particularly used for sort of planning and design tasks by other stakeholders in the energy sector, that if you want to sort of export the data that or the grid topology that you use in your model, but you don't want to export it in sort of a SIM format, it might be interesting to see if you could sort of translate it to an ESDL format that can be used in more sort of generic, more abstract grid planning and design sphere. Pierre?
Thank you. Thanks for the presentation, Thomas. I have a question that's maybe sort of one level up, half more orthogonal, but I'll ask it anyway. What's your vision on like what large language models and generative AI might bring to the field of like competing standards and maybe helping with like compatibility layers? Do you think it's a technology that we could rely on to solve this in the coming years? Or do you see this as something that might not bring as big promises as we might think?
I don't know. I think the first thing that comes to mind is it could help, but probably it's a smarter thing to structure your data first properly according to a particular data model. And if you then want sort of one model to map onto another or generate sort of an energy system in one particular type of language, then I guess you definitely could use it. But I think if we have the complexity solved by large language models, for example, without first sort of compartmentalizing and sort of creating a clear overview for us humans, then I think it could become kind of messy and less transparent. And I think one of the issues was also that you do want that transparency. You do want to be able to trace down what kind of underlying data and assumptions are made in each different model. So I would say experiment with the different AI and use it as such, and at the same time also structure your data according to something that we as an energy sector see fit. Has anyone else opinions on AI? Any more questions? I think we're almost there. Is there an ontology that anyone here in this room uses and is feeling offended that it didn't show up? The overview picture, or that is simply not there and you want to share? No? Oh, I mentioned all of them. Amazing. All right. Jorrit, any last words? No?
No, join the meetup tomorrow if you want to contribute to this ESDL ecosystem and
Yes.
discussing the tools and ontologies and their interoperability.
For sure. And there's two tools that that Jorrit would elaborate a bit on. But it's in 2 minutes. That's maybe a bit too short time. But if you think, hey, this does sound interesting, then tackle Jorrit on the way out.
Yeah. So maybe the short pitch in 2 minutes.
Sure.
I is a market model for wholesale energy market modeling, time series based, in which assets create bidding functions, and for every time step market clearing happens. In this way you can simulate the effects of the bidding strategies, but also the type of assets in your system for future scenarios. And for example, what would happen with electricity prices if coal-fired power plants would be phased out? These kind of questions you can ask. DOTS is a co-simulation platform built with a microservices philosophy in mind, also relying on cloud-native philosophies. And in this way, we can easily scale up, parallelize simulations for the questions in the energy transition. So it's more a framework than a simulation tool itself. And if you want to know more, then please find me. I'm here today and tomorrow. Looking forward to continue the conversations.
Enjoy your time. Thank you for your attention.